Welcome back to ISO Math, and we are still talking about vectors. So now we are going to move to vector addition. How to add two vectors. Here I have vector u and vector v, and we want to do u plus v. And it turns out this is really simple. I mean, it's a nice simple definition. As I said before, these vectors have no position. So I can take that vector v and just so it goes over 1, 2 and up 1, just move it. There is vector v. That is still, that is the same vector as I have down here at the bottom. So if I do the vector u and I add the vector v at the end of it, I get, let's see, new color. I'll just do white. I get this vector here, and that vector is u plus v. So this is vector u plus vector v. Okay, and the way we get the, to get the coordinates of it, or if we consider it as a vector that starts at the origin there, all we do is look at, so vector u has what, over 1, up 3, plus vector v is over 3 up 1. I'm sorry, over 2 up 1. Okay, and if you look at it here, see if I can get a different color. So for vector v in the x direction, I go over 1, and then for vector u we go over 1, 2. So that in my x direction, this thing is, you simply add those coordinates, 3. And then the vertical direction, let's see, the vector v goes up 1, 2, 3, and then the vector u goes up 3, and the vector u goes up 1. So it's going to be 4. So you simply, to get the x coordinate 1, 2, or it's not really the x coordinate, but to get that, if we consider it as a position vector starting at the origin, to get the direction, to get the value in the x direction, we simply add the two values of u and v. To get the value in the y direction, we simply add those two. 3 plus 1 is 4. So to get that vector is the vector represented by 3 in the x direction and 4 in the y direction. Okay? Oops, I don't want to do the dot product yet. Let's do vector subtraction. Now, first of all, let me talk about our regular subtraction. This is because I find vector subtraction to sometimes be confusing just to look at it. So if I wanted to do 5 minus 3, well, we know that equals 2. And we know that equals 2 because 2 is what I add to 3 to get to 5. Okay? So, for example, if I do u minus v, I need to figure out what I add to v to get to u. That is, what vector do I add to v to get u? Okay, so if we look at it over here, and vector addition is simply going to the end point and putting the vector there. So if I go to the vector u and put this vector here, to the vector v, and put that vector u, put that vector to the end point of u, that gives me, let's call that vector w. Go to the u v plus w equals u. That's where we end up. If we do the vector v and we do the vector w, we end up on this vector here, u. Okay? So it's going to be w that I've labeled there, vector w. Okay? And clearly, if we just by inspection, w is going to equal a -1 in the x direction and up 1, 2 in the y direction. Okay? And if we look at the vector u equals what, 1 in the x direction and 1, 2, 3 in the y direction. V equals 1, 2 in the x direction and 1 in the y direction. So when we do u minus v, so u minus v, we simply do 1 minus 2, -1, 3 minus 1 is 2. And it matches up with our, hopefully our intuitive geometric inspection that u minus v is going to be the vector -1 in the x direction and 2 in the y direction. Okay, we've got 6 minutes, we've got a couple minutes left, so let's talk quickly about the dot product. And the dot product will take a little more explaining, so I'll do a quick example here with the dot product of u and v, and then we'll make another video that spends a little bit more time on it. So our vector u equals 1, 3. Our vector v equals 2, 1. And what we're going to talk about is the dot product. So we're going to do u dot v. It's going to be a dot u dot v. And this is a new definition for you. So when you do u dot v, it's simple enough. Do the x direction times the x direction, 1 times 2 plus the y direction times the y direction. It's going to be 3 times 1. Oops. 3 times 1. That's going to equal 2 times 1 is 2 plus 3. The dot product here is going to be 5. So the dot product is always the x's times the x's and the y's times the y's. And we will show in the next video that there's another way to get the dot product, and that's going to be u dot v equals the magnitude of u times the magnitude of v times the cosine of theta, where theta is the angle between the two vectors. And what that is going to do is it will project this u on the v, and it will tell us how much, if we're thinking in forces, I always find this stuff much easier to talk about in terms of force. It will tell us how much force this vector u has in the v direction. Okay? So in the next video we'll talk a little bit more about that. See you then.